students. Today we will discuss about vectors. Physical quantities can be classified into three categories. One is scalar quantities, another is vector quantity, third is a tensor quantity. Basically, if we discuss about these two, scalar and vector quantities, scalar quantities, those physical quantities which can be described completely only with their magnitude. For example, suppose mass of an object 5 kg, it's enough information. Okay? You are describing it with the magnitude. Okay? There is no need of direction. Physical quantity which can be described completely only with its magnitude, we call it as a scalar quantities. Another category is vector quantity. Vector quantities, those physical quantities which can be described with magnitude as well as direction. Direction is also important here. This kind of physical quantities are called as vector quantities. For example, suppose if you say force acting on an object is 10 Newton. 10 Newton is not sufficient information here. Its direction is also important. In which direction it is acting. Okay. So that way, with magnitude, if direction is also required, then that quantity you can represent it as a vector quantity. And the vector quantities are represented with symbol of arrow, which indicates the direction. Third category, that is tensor quantity. Some physical quantities which have a magnitude also, which have a direction also, but then also they are not coming into the category of vector quantities. That kind of quantities you can call it as a tensor quantities. Vector quantities, they obey vector law of addition. In this chapter we will study about the vector law of addition. These quantities, even if they are having the direction, but they are not obeying vector law of addition. For example, simply if you take an example of electric current, let's say electric current is flowing through this wire, let's say 10 ampere current is flowing through this wire. If this is splitting into two branches, let's say in this branch it is 3 ampere, in this branch it is 7 ampere. Okay. Amount of current flowing in these two branches is not depending on the angle between these two branches. It is independent of this angle. Whatever be the angle between the two, current flowing through that branches, that will be same. So here this is not obeying vector law of addition, and that's why that is considered as a tensor quantity. Now we focus on this vector quantities in this chapter. Any physical quantity which has a magnitude as well as direction, and if it is obeying vector law of addition, then that quantity is considered as a vector quantity. Various examples of vector quantity you might have studied, that is in mechanics, kinematics, let's say displacement, velocity, acceleration, momentum, force. These are all various examples of vector quantities. Now, before we discuss about that, let us discuss some types of vector quantities. So, parallel vectors. Two vectors, they are called as parallel vectors. If both the vectors, let's say vector A, vector B, vector quantity, it is represented with magnitude as well as arrow. Arrow indicates that it is a vector quantity. So here A and B both are vector quantities. Both vectors, they are in the same direction, so they are called as parallel vectors. So two vectors are called parallel vectors if they are in the same direction. Another is equal vectors. If two parallel vectors are having equal magnitude, let's say both vectors magnitude is equal. Magnitude of vector A is equal to magnitude of vector B. Magnitude of vector you can represent with this symbol vector in between two vertical lines. So magnitude of vector A and magnitude of vector B, it is equal as well as both are acting in the same direction, then you can say that vector A is equal to vector B. A and B both are equal vectors. So two vectors are equal vectors if their magnitude is also same as well as the direction is also same. Another is anti-parallel vectors. If two vectors are in the opposite directions, let's say vector A and vector B, if they are acting in opposite directions, then they are called as anti-parallel vectors, and again their magnitude is equal, then you can say that these two vectors are opposite vectors. So opposite vectors, they have equal magnitude but the directions are opposite, so you can write A is equal to negative of B. Both have equal magnitude but the directions are opposite. So these are the different types of vectors. Another is co-initial vectors. If two vectors, their initial points are same, let's say vector A, vector B. See, when we represent any quantity vector, this is arrow that is called as head and this is called as tail. So if tail of the two vectors they are same point, or you can say if two vectors they are co-initial vectors, initial points are same, then these two vectors they are called as co-initial vectors. Another is null vector. If any vector having zero magnitude, then it is called as null vector. Now zero magnitude means how can you call it a vector? Yes, suppose for example this is an object. On this object one force is acting from this direction, it is of magnitude 10 Newton. Another force is acting from this direction, its magnitude also 10 Newton. What is the net force acting on this object? So here both the forces are acting in opposite direction, equal magnitude it is, so net force acting on it is 0. So magnitude of that force is 0, but it is a vector quantity because force is a vector quantity. So it has a 0 magnitude, then what is about the direction? Direction can be any. So null vector, also called as zero vector, is a vector having 0 magnitude and any direction. Next is unit vector, also called as scap vector, because the vector, let's say unit vector A, if I want to represent unit vector, it is represented with vector with above its cap. It means that it is showing unit vector. What is the meaning of this? So unit vector is a vector having magnitude of 1 unit. Suppose this is any vector A, if I divide it with its magnitude, vector A, if it is divided with its magnitude, the amount, same number with it is divided, then the ratio is 1 and the direction is same as that of vector A. So unit vector A is the vector A divided by its magnitude. In Cartesian coordinate system, along x direction I cap is the unit vector, along y direction j cap is the unit vector, along z direction k cap is the unit vector. So I, j and k are the unit vectors along x, y and z direction. Again, unit vector is the vector having magnitude of 1 unit and having a particular direction. It means that I cap is the unit vector along x direction, j cap is the unit vector along y direction and k cap is the unit vector along z direction. Now, component of vector in 2 or 3 dimensional space. Let us consider in this xy plane, coordinate of any point are x and y. Let's say we mark this point as P. The coordinates of point P are x and y. What it means that if you take the intercept on x-axis, this distance is x. If you take intercept on y-axis, this distance is equal to y. If we represent this position of this particle with respect to origin, this indicates the position vector. Let's say represented by symbol r, position vector r that represents the position of point P in xy plane. Now, with trigonometry, if we see for this right angle triangle, if this angle is theta, theta is angle vector r, it makes with x axis, then for this right angle triangle adjacent upon hypotenuse, that we call as cos theta, opposite upon hypotenuse that we call as sin theta. So here x by r is cos theta, y by r is sin theta. So from that you can write x is equal to r cos theta, y is equal to r sin theta. So here we have written the value of x and y in terms of vector r. Okay. Now the components of vector, when we write vector r, it is in a two-dimensional space, so it has a component along x direction also, component along y direction also. Along x direction, what is the magnitude of that vector? That is r cos theta. Along y direction, it is r sin theta. So r cos theta and r sin theta, that represents a magnitude, whereas I cap and j cap represents unit vector along x and y direction. So vector r is equal to r cos theta I cap plus r sin theta j cap. Okay. So this way you can write the component of r into x and y directions. Okay. Similarly, if it is the vector in three-dimensional space having components x, y and z, then you can write vector r is equal to x I cap plus y j cap plus z k cap. So this way you can write the component of vector into different directions. Here you must know that what is the axis with which angle theta is made. Suppose this same vector r, if it is making angle theta with y axis, vector r, if it is making angle theta with y axis, then in that case, if you write the components, so here again coordinates are if x and y, so here value of x is equal to and y equal to, say for this angle, adjacent upon hypotenuse, that is y by r is equal to cos theta, so y is equal to r cos theta, and similarly opposite upon hypotenuse, that is x by r will be equal to sin theta, and that's why x will be equal to r sin theta. So in this case you can write the components of vector r as r sin theta I cap, r cos theta j cap. So here it was r cos theta I cap, r sin theta j cap, because theta was angle with respect to x axis. Here theta is angle with respect to y axis. So it became r sin theta I cap plus r cos theta j cap. So this you have to remember. Next is vector addition. Vector addition, there are two laws. One is triangular law of vector addition. What it says that if two vectors, let's say vector A and B, two vectors are represented with their magnitude and direction in the same order. You can say vector A tail, head, vector B tail, head, tail, head, tail, head. They are in the same order. We can consider it as an anti-clockwise direction. Then the resultant is the third side of triangle with magnitude and direction in opposite order. You can say tail, head, tail, head, head, tail. Means for this vector r, we can consider it as a clockwise. A and B, if they are anti-clockwise, resultant is clockwise. So directions are in opposite order. So this is what the statement. If two vectors are represented with their magnitude and direction in the same order as two sides of a triangle, then resultant is the third side of triangle with the magnitude and direction in opposite order. Here resultant of this two vector r is equal to a plus b. See, this is a vector addition. It is not like that algebraic sum. Suppose vector A, if it is 10 Newton, vector B, if it is 7 Newton, then r is not always a plus b or 10 plus 7, 17. It depends on the angle between these two vectors. Now the question that is, what is the angle between vector A and vector B? So here, vector A and vector B, the angle between two vectors, first of all, it is the angle between their directions. Angle between two vectors means it is angle between their directions. And you can see vector A, it is acting along this direction, vector B is acting along this direction. So angle between these two vectors, if you want to represent, this is the angle between two vectors. Theta is the angle between vector A, which is along this direction, vector B along this direction. Similarly, another is parallelogram law of vector addition. According to this law, if two vectors A and B, if they are represented as a two sides of parallelogram, first of all, parallelogram is that having opposite sides are equal and parallel. So here A and B are the two vectors, they represents two sides of a parallelogram. Then resultant is the diagonal of a parallelogram with the same initial point. statement that the two co-initial vectors represents the two adjacent sides of a parallelogram. The resultant is the diagonal of a parallelogram with same initial point. So here also you write R equal to A plus B. Now, what is the difference in these two? It is the representation of vectors. Here, two vectors are represented in this way as two sides of a triangle. Here, these two vectors are represented as two co-initial vectors. Here also, angle between two vectors A and B, if it is theta, whatever is the value of R in this case, same value of resultant you will get in this case also. Here also, you have written R is equal to A plus B. Okay. So this is a statement. Okay. Actually, what is the magnitude of this resultant vector R, and what is the direction of the resultant vector R, that we can calculate with analytical method. So let us see how to derive the expression of magnitude or direction of resultant in addition of two vectors. Let us consider two vectors A and B. Vector A, this is vector B. Vector A and B, they are inclined to each other by angle theta. If you want to find the resultant of these two vectors, resultant R, to find it, let us first take the components of this vector B in horizontal and vertical direction. Vector B, if it is inclined with x-axis by angle theta, then this component will be B cos theta. Opposite will be B sin theta. This is also called as the resolution of vector into its component. Cartesian coordinates, B cos theta, B sin theta. If we mark all these points at, let's say, A, B, C and D, you can see triangle ACD. It is a right angle triangle, and if we apply the Pythagoras theorem here for triangle ACD, AC square plus CD square will be equal to AD square. AC is the sum of AB and BC. So you can also write AB plus BC square plus CD square is equal to AD square. Now if you put the magnitude of these values, AB is vector A, magnitude of vector A, BC is component of B, that is B cos theta, CD is B sin theta, AD is vector R, magnitude of that R square. So if you expand this, it is A square, B delta is 2AB cos theta, B square cos square theta. This is B square sin square theta, that is equal to R square. If you see this, if you take B square common, there is identity sin square plus cos square theta value is 1. That's why you get A square plus 2AB cos theta plus B square is equal to R square. So from this, you can get value of R, means you can say magnitude of vector R is nothing but under root of A square plus 2AB cos theta plus B square. So this is the equation for magnitude of resultant. You can see it depends on the value of A, B as well as angle theta between vectors A and B. About the direction. Direction of vector R. You can see vector R. Let's say it is making certain angle alpha with respect to vector A. Then again for this right triangle you can say tan alpha is opposite of one adjacent. You can write again for triangle ACD, tan alpha is equal to opposite, that is CD upon AC. And again this AC is AB plus BC. And therefore you can write tan alpha is equal to B sin theta upon A plus B cos theta. And therefore alpha is tan inverse B sin theta upon A plus B cos theta. This way you can find the direction as angle in this octave means we are getting the direction of r with respect to vector A. So this is the equation for magnitude. R, and this is the direction of r with respect to vector A. This way we can find out the magnitude and direction of a resultant. Let us discuss some problems on this vector addition. Let's say two forces, if they are inclined to each other by angle 90 degree, what is the resultant of this? Here, in all this case, if we apply the equation for resultant, F net is equal to under root of F1 square, F2 square, F1, F2 cos theta. Here F1 and F2 both are equal. Theta is 90 degree. Cos 90 value is 0. Cos 90 value is 0. This term will be 0. It is under root of F1 square plus F2 square. And F1 and both are equal. It is under root of F square plus F square. So under root of 2F square. So we can write resultant will be equal to root 2F. This is what Pythagoras theorem what we say. If two vectors are perpendicular to each other, the resultant will be root 2F. If both the vectors are equal. If two vectors are in the same direction, in that case theta is 0, cos 0 value is 1. And that's why in this equation if we put the value with F square plus 2F square. So it is 4F square. So square root if you find it is 2F. So resultant will be 2F. In this case, theta is 180 degree, cos 180 is minus 1. So as it is minus 1, it is F square plus F square minus 2F square. So F square 2F square minus 2F square is 0. So magnitude will be 0. See, two vectors in the same direction, we are just adding the magnitude. If they are in opposite direction, we are subtracting the magnitude. They are perpendicular to each other. Okay? According to Pythagoras theorem, these three things are known. Apart from this, whatever the angle between the two vectors, let's say theta is 60 degree. Value of cos 60, value is 1 by 2. Cos 60 is 1 by 2. So if you put the value in this equation, it is F net will be equal to under root of F square plus F square plus 2 into F into F, that is F square into 1 by 2. So it is F square plus F square plus 3F square, so it is root 3F. Resultant will be root 3F. If theta is 120 degree, cos 120 is minus 1 by 2. And if it is minus 1 by 2, then in that case F net will be equal to, here it is F square plus F square minus F square. Cancel. So it is under root of F square, so resultant again it is equal to F. So this way, whatever the angle between two vectors, you can find out the resultant of